So please welcome me in joining our first speaker, Sean Moriarty. Sean is the author of Genetic Algorithms and Machine Learning, both in Elixir, and the author of NX and creator of Axon. So Sean, I'm really excited to hear what you're going to teach us today. So let's get this party started.
Thank you. Yeah, you're good. Okay. Test, is my mic on? Yes? Okay, awesome. All right, just give me a sec to get this set up. Go in here. I just learned how to do this today. I've never successfully used Speaker View for a conference before, so this is the first time. Hopefully this means that this is going to be the best talk I ever give. Awesome. So hello, everyone. My name is Sean Moriarty. I'll do a little intro of myself a little bit later on. This is actually the first time that I've been able to make it out to CodeBeam. They've extended the invite for a few years now, and it's never worked out for me, so I'm very excited to be here. This is also the first time I was invited to give a keynote, which is also pretty cool. Also the first conference I've been at where you get to rate the talks, so it might be the last conference I ever speak at, depending on how the ratings work out for me. I also have a tendency to do this thing leading up to conferences where I complain to my wife that I'm never going to give a conference talk again. And then inevitably I give the talk and agree to do another one. So I will welcome you all to now the third or fourth last conference talk that I'll ever give. Hopefully it's the best one. The title of my talk is Designing LLM-native Systems. And I think that probably sounds a lot cooler than maybe what I'm going to talk about. I have a tendency to do this thing where I title my talks before I actually write them. And then I go through and write them, and they end up being completely different than what the title says. But I feel obligated to keep the title identical to what's advertised on the website. That said, this is the closest I've stayed, I think, to the contents or to the title. The content is the closest I've stayed to the title of the talk. And I think this is something that is a topic that's important to talk about. So I'm excited to do that. Before I get into it, I do have to do a quick little disclaimer. Maybe the last time I'll ever have to do this. The views expressed in this presentation are those of the speaker and do not represent the views of the United States government, Department of Defense, or Army Cyber. So, bummer out of the way. Brief introduction to me. I am the author of Genetic Algorithms in Elixir and Machine Learning in Elixir. I got my start on the Beam in college, and honestly have been super interested in it ever since. I've been writing the Beam for now almost 10 years. From there, I kind of parlayed the books into, I think, the best early years that a software developer could ask for, working alongside Jose Valim, Jonathan Klosko, Paulo Valenti, and a number of other people in the Elixir machine learning ecosystem. Learned a lot from them. It was a lot of fun. More recently now, I've been working on building frontier code models at Magic. So if you're interested in talking about that, please come and see me, because we are hiring. And I also am a self-perceived amateur LLM philosopher, which I think is what qualifies me to give this talk. So hopefully I'm an authority on this subject. If you were at MPEX a few years ago, you might have watched this talk or seen this talk on YouTube. I, as I'm sure like many of you, have gone through a series of existential crises as I've watched large language models get increasingly better at software development. And I've done a lot of thinking about what that means for me, what that means for NX, what that means for the future of software engineering in general. And this talk was kind of like an early manifestation of the thoughts that I had had. And if you watch this talk, it's kind of just like me rambling about different technical decisions and things that happen when you're building LLMs. And I had failed to realize at the time, I think, that the things that people care about in tech, or the problems that people care about in tech, are not necessarily actual technical problems, but social problems. And this is something that I keep coming back to in my later stages of my career. Now, when I say late stages, it's funny because I'm very early on in my career. But I had failed to realize basically that people don't necessarily care about technical solutions to problems, but actually they care more about the social solutions to problems. And I think I had completely sort of missed the point on that talk. When I was designing this talk or writing this talk, I had thought a lot about going super into the technical weeds again, but then I realized that none of that stuff really actually matters. And so the implication of this is that we can have all of these things that are true when it comes to large language model adoption. Okay, so we can have models that keep getting smarter, context windows that keep getting larger, inference that keeps getting faster, and then people still won't use LLMs to their full potential, or maybe even at all. I had a friend call me the other day, he's not a programmer, and he said to me, hey, Sean, like, I just listened to a podcast. Do you know what AI agents are? And like, I had to laugh a little bit because I was like, okay, yeah, obviously, I think everyone knows what AI agents are. But then you talk to people outside of our little tech bubble, and you realize that this is not like a mainstream thing yet. And it has nothing to do with like the technical capabilities of the models that we have, and everything to do with the interfaces people use to interact with them, the messaging around them. It's all a social problem and not actually a technical problem that we need to solve. I like this little meme here is that the obvious hardest part of getting AGI is not actually getting AGI, but it's changing human behavior to take advantage of the AGI that we have. And I should know this better than anybody because for the last 10 years, I've used Sublime Text 3. I've never actually changed my text editor, and I don't plan on doing it anytime soon. I love Sublime Text 3, unlicensed as well, unfortunately. So we are and always have been the true bottleneck to the value that large language models can provide. We need to change the way we build our products, organizations, and our own workflows to truly realize the potential of a large language model. So I'm going to talk about 3 different aspects of large language model application. So the product, your organizations internally, and then your own workflows as well, and some of the implications of these. So we'll start with products, because I think these are the things that people care the most about, is how do we build products on top of large language models. And I'm sure your companies are all working on very similar things. You probably had someone come up to you and say, hey, how can I use a large language model in my application? And it's pretty obvious why people want to do this. You look at these charts. I think these charts are going everywhere. You'll see we're essentially in the middle of a gold rush. All of these companies here, the curves just keep getting steeper with respect to AI. So Cursor, obviously, one of the fastest companies to reach 100 million AAR, or to go from 1 million to 100 million AAR. And I think this is a trend that's just going to continue. And so, like I said, you obviously will have people in your companies, maybe not necessarily technical people, but they're going to ask you, how can I integrate LLMs into my products? And I have a funny anecdote. I had another friend who's starting a B&B platform similar to Airbnb, but targeting like military veterans. And he said to me, like, how can I integrate AI and LLMs in my application? And I laugh, and it's kind of like reminds me of this meme. Your scientists were so preoccupied with whether or not they could, they didn't stop to think if they should. And I think this applies a lot with large language models. In that talk I referenced earlier, I talked a lot about how people just want to sprinkle a large language model on top of a product and then say that it's more valuable. And it's not necessarily the case, because you need to think carefully about how you go about designing your products to integrate large language models in a way that's safe and also valuable to your customers. So I think the obvious way that people want to integrate large language models in top of their application are chat interfaces. And it makes sense. Your first exposure to a large language model is through ChatGPT for the most part. So I think it makes sense that people's natural applications, that the first one that they go to is, how can I build a chat interface on top of my product? And I think that's a mistake. But I think the quintessential example of this is if you've ever played with the GPT-3 playground, this was the early interaction that people had with these large language models, this GPT playground. And there wasn't really much of a capability jump between like ChatGPT, GPT-3.5, and then some of the later iterations of GPT-3 that you could play with in the playground here. Really, the thing that changed, that made it so valuable, was actually the interface. Because chat interfaces, when you're chatting with something that's realistic enough, they're addicting to us. And it just like has, it goes to our like psychology as humans. We like to interact with things. We are social beings, so we like to interact, we like to chat. And so ChatGPT got infinitely more valuable when they slapped this chat interface on it, and it was something that you could naturally interact with. If I were to show this to like a consumer, my wife, for example, she's a huge ChatGPT user, but she's not really a technical person. She would have no idea what to do with this. But if you give her an interface like this, she uses this every single day. It's one of the most valuable things that's been introduced to her job, to her profession. ChatGPT has people boxed into believing that large language models start and end with chat. And I'm here to tell you that that is not at all the case. And in most cases, actually, you should never build a chatbot. You can do so much better than just a chatbot with your company's proprietary data. And that seems to be the most common use case people go to. But I'm here to tell you that it's not the best use case that you should go to. It turns out that chat interfaces are really, really hard to get right. And there's a couple of reasons for that. So the first thing I'll go into is this thing called the ELIZA effect. The ELIZA was a chatbot built in 1966 at MIT. You can go find the source code online. It's written in like Common Lisp or something like that, and there's re-implementations in a whole bunch of other languages. Built in 1966, it wasn't very good. So if you chat with it, it essentially just like inverts what you're saying and reflects it back on you, sort of like a therapist would. But the thing is that people would still interact with it as if it were human. It was still capable of eliciting emotional responses from people. And the reason is because we have a tendency to anthropomorphize AI. So we have a tendency to treat AI as if it were human when we're interacting with it, which has some interesting unintended consequences when you're designing a product. So we have high expectations for our interactions with the agents of companies we work where we interact with. So we place a lot of trust. If I'm chatting with your company's chatbot, I place a lot of trust that that chatbot, what it's telling me is true, that it's not going to mislead me, that it's going to give me honest answers. And when that fails to meet our expectations, that trust is broken forever. So your chatbots can do a lot of damage. Also, LLM failure modes, especially when you leave them in these sort of unbounded use cases, are extremely non-deterministic. So if I build an application right now on traditional software, not on top of large language models, I have a pretty good understanding of how that system can break and what kind of damage that can do. With an LLM, and if you leave it open-ended, you have no idea the ways that your system can break and the damage that it can do. The other thing is that they don't know when to say no. So you're not going to get an LLM that's going to refuse to answer someone's question because they're trying to be helpful. And the consequence of this is that you end up in a situation where you have a tool that is extremely valuable in isolation, but can actually make your product worse and even do irreparable damage to your brand. So the moral of the story is don't build chatbots. But then you ask the question, if I'm not going to build chatbots, then what should I build? And I kind of look at like the products that you can build on top of LLMs through the lens of this LLM economic pyramid. This is not very rigorous academic study, but it's my theory, so bear with me. At the top of the pyramid, or the base, depending on how you look at it, you have hardware and energy providers. These are people like NVIDIA, some of the people that are building their own custom chips, obviously like the power grid. Then you have model and inference providers. So these are obviously like OpenAI, Anthropic, Google. You could even put cloud providers in here, some of the inference providers like Modal Labs. Then you have what I would call LLM enablers. These are applications that build infrastructure or provide proprietary data for large language model-based applications. Then we go into LLM wrappers. So these are the traditional GPT wrappers that people had used disparagingly, only to find out that they're actually some of the most valuable applications of AI right now. And then there's the LLM consumers, which are essentially the rest of us. These bottom of the pyramid or top of the pyramid, depending on what you're looking at, are probably the things that most of us care about. They require the least amount of resources to build, and they're essentially the most common applications of large language models. I'll talk a little bit about LLM enablers, because I think this is like a piece that people miss a lot. These are products or infrastructures which enable customers to apply LLMs in unique domains. So there's a lot of these companies popping up right now. I think you'll see, if you're on Twitter right now, a ton of people talking about Anthropic's Model Context Protocol. That is something that I would consider an LLM enabler, because you can attach a large language model to some unique piece of infrastructure. Something like giving LLMs access to browsers, access to virtual machines, access to proprietary data. Then we have the wrappers, which are products whose primary value is derived from building LLM-enabled customer experiences. These are like somewhat new classes of products where you have something that before LLMs would have been basically impossible to build, or would just not have been that valuable. And now with large language models, they're extremely valuable. And then the consumers are the rest of us. So these are people like my dad, who's a CPA, who calls me up every other weekend and asks me how he can use ChatGPT. Now, I can't tell you exactly what to build because I don't know what you're interested in, but I can give you some rules of thumb when it comes to deciding how you can apply products or apply LLMs in the products that you're building. So the first rule of thumb, as I would say, is build products that get exponentially better with smarter models, longer context windows, and faster inference. These are things that are going to inevitably happen over the next 1, 2, 3, 4 years. And if you have built a product that you can essentially plug a new model into and get better performance for the price point, you've built a product that's extremely valuable. The next thing I would say is build for a world where your products are increasingly used by agents. I think this is something that people maybe take issue with at times because they don't want Anthropic or whoever else scraping their data. But I think this is something that is essentially inevitable. There's some interesting examples of this. So like John Carmack has this tweet where he says, LLM assistants are going to be a good forcing function to make sure all app features are accessible from a textual interface as well as a GUI. And I think that's like sort of an underrated statement. We're moving from the world of progressively more complex design and back into the world of just like terminal-based UIs and text-based UIs in order to make our applications accessible from large language models. There's also a cool demo that I don't know if this will work, but if you have seen this, it's pretty interesting. This is a demo of the Gibberlink protocol, or like the GG-Wave protocol, which is essentially an audio protocol that two interfaces, two computers, agents can use to interact. So if audio works, we'll see. OK, I don't think it's going to work, but it's OK. Oh. I should stop moving my mouse, maybe. OK. Well. Speaker view didn't turn out very good. If you watch the video, essentially what you have is you have two AI customer support agents, these conversational AI support agents. They start speaking in English, and then when they realize they're AIs, they switch to this binary protocol that is not understandable by humans, but it's more efficient for them to communicate in. I think that's a little bit of a meme in a way. I don't necessarily know how practical that is, but I think it's a good example of where you should be thinking on how you can build your systems that they're easier or more accessible for agents to interact with. The other thing I would say is build on top of structured outputs. If you've seen me talk anywhere on Twitter, I talk a lot about this instructor library. If you haven't heard of it, I would highly recommend you go look it up. It's essentially a library that allows you to define ectoschemas that you can then take unstructured data, such as text, and turn them into ectoschemas. So you can model your domain from unstructured data. Simon Willison has this blog post where he talks about structured data extraction. He does a much better job describing this concept than I would. But it's something that I think anybody and everybody should read. It's extremely, extremely, extremely valuable. One of the things he says in this article is he says, I've suspected for a while that the single most commercially valuable application of large language models is turning unstructured content into structured data. And I think this is something, if you've built a product, you probably understand that there are so many applications of this. The applications of this are extremely unbounded. You can apply this in essentially any domain. So absolutely build on top of structured outputs. The other benefit you get with structured outputs is that you understand the failure mode. So you go from having a large language model generating unbounded outputs, non-deterministic outputs, to something you can understand, something that you can constrain, and then you understand the failure modes and you understand where things can go wrong. The other thing I'll say is build your own evals. So if you're building a product on top of large language models, it's impossible to know if a large language model is actually better than another one unless you build your own evals. So you can depend on the general purpose evals, like human eval, SweBench, whatever. But if you don't build your own evals, you don't actually know if a model is better for the applications that you're building. A lot of people don't take the time to build their own evals, and I think it ends up costing you more money in the long run. This is something I see a lot. People saying that they're building the Zapier of the AI age or the legacy company of the LLM era. And this is something that you don't want to do. You don't want to build the insert legacy company of the LLM era. The reason is because the interfaces, the apps of today were designed on interfaces for the pre-LLM era. We are living now in the post-LLM era. We should build interfaces that are suitable for the post-LLM era. And I don't actually have a good answer for what these interfaces are. That's why I'm proposing the question out to all of you. It's just something I think about a lot, is that we built the web, we built mobile apps, we built GUIs for us to interact with, for not agents to interact with. And in many ways, we're now shoehorning LLMs to fit into spaces that are suitable for us, but not necessarily suitable for them. And so we need to start thinking about how can we build interfaces that are suitable for LLMs to interact with and that empower us and empower them. The other thing I'll say is we are still extremely early when it comes to product design with large language models. There's a tweet asking, what is the currently best solution for turning a large collections of personal notes and chats into an LLM interrogable data set? And that sounds like the quintessential large language model use case. This is chat with your data. And the response is still build your own using an API key in a vector embeddings database like Chroma. And that's like the introduction to large language models application. And we still have not evolved a product beyond that for the use case that he's asking for there. And we're almost 3 years past ChatGPT. So we are still extremely early when it comes to product design with large language models. Now I'm going to transition to something I think is a little more internal facing, a little more applicable to all of us here, is your organization and large language models. So I'm sure everybody here working in the tech industry is using large language models in their organizations in some way. Probably the most common application, I would say, for all of you is just code generation. In one way or another, your organizations are using large language model-based code generation. So I'll walk you through a scenario that I'm sure all of you have been in before. You give an engineer a task, and this is something I just generated with Claude. Write a module for processing customer orders that handles prioritization, discounts, and inventory allocation. This is an extremely specific task. It could be like a linear ticket or a GitHub issue. But you haven't gone into any like design details here. It's just kind of the title. You're not talking about the trade-offs. It's just an instruction. Your engineer takes that task, and they disappear for 15 to 20 minutes. They're working fast here. And then they send you a PR. And you're like, wow, that was pretty quick. This is a pretty extensive ticket, but that was fast. Let's see how we did. And then you look at it, and you see a module, and the module doc is like, module for processing customer orders that handles prioritization, discounts, and inventory allocation. And your mind, you start to like trigger a little bit, and you're like, OK, well, that's exactly what I had described. So they're really following instructions very, very well here. But I would have liked the module doc to maybe talk a little bit more about the implementation details, but OK. And then you scroll down a little bit, and you see the first function. And now all of the alarm bells are ringing because you see a comment after every single line that's describing exactly what the next line is doing. And immediately you're like, OK, this is 100% AI generated, which is not necessarily a bad thing. It's a bad thing in isolation. It's a bad thing when you don't think about it. And there's reasons for this. So the first thing that is bad about this is that LLMs are increasingly allowing engineers to offload thinking, but at what cost, right? First, you shift the burden of systems thinking to the reviewer. I don't know about all of you, but I absolutely hate reviewing code. It's like one of my least favorite things to do, to put myself in the mind of another person and try to figure out what they're trying to do. Some people make it very easy to review their code because they describe their implementation and make it extremely easy to follow along what they're trying to do. But when I get something that's like AI generated like that, now I need to decide what the programmer was thinking. And in many cases, I need to decide what the large language model was thinking. And I can't actually go ask them, hey, why did you build it this way instead of this way? It's fundamentally harder than putting the burden of systems thinking on the programmer. The second thing is you end up delegating responsibility to a system which cannot provide you with historical context and which does not have the historical context of your organization. And quite frankly, a large language model does not care about the problems in your organization. They have this limited context window. You ask them to solve a problem, and they don't have any of the context of the years past leading up to this problem. And they're not going to be there to provide you with any context after they solve this problem. So you can't really pin them down or hold them accountable for generating a solution that doesn't necessarily work in the way that you intended it to. Third is you are accepting a potentially complex change, which you may not fully understand. I'm sure all of you have been through this process of debugging with Cursor or Claude or something like that, where you ask it to build a complex system, and you make it like 30 minutes into this, and everything's going great, and then it just completely goes off the rail. And then you have to sit there for about an hour, hour and a half to try to figure out what this AI-generated code is doing so you can actually fully understand your system. Nice meme here. Vibe coding is this new thing that everybody's talking about on Twitter, where you just talk to an LLM like with your voice and then have it generate code for you. And you end up in these scenarios where you're telling Cursor or Claude or someone else to please fix like 30 times until you finally decide, OK, we're going to rewrite this entire thing from scratch. Fourth, or finally, is you're stunting your own growth when you are doing this, when you're offloading your systems level thinking to large language models. I think this is a funny, like it's a little disparaging, but a funny something that's happening. I've noticed it happening with myself when I use these large language models is I think we are underestimating how stupid ChatGPT is making people. Especially when you're introducing yourself to new subjects, using a large language model is incredible for education if you use it and apply it in the correct way. But if you don't, then you essentially end up learning nothing. And there's actually like research to back this. A new paper from researchers at Microsoft and Carnegie Mellon University finds that humans increasingly rely on generative AI in their work, and they use less critical thinking, which can result in the deterioration of cognitive faculties that ought to be preserved. I think this is something that you'll see a lot with newer generations of engineers that are increasingly relying on LLM-generated code, and LLM code assistance, because like I said, you're essentially offloading the critical thinking skills that you need to solve problems, and you're stunting your own growth in doing so. So yeah, more and more engineers will grow up lacking the systems level thinking required to be successful. Now, the thought you might have is, okay, well, am I just not supposed to use AI-generated assistance at all? And that's not what I'm saying. I think AI-generated assistance is incredible. It's a huge productivity boost. I've been able to solve problems with LLM assistance that I don't think would have been possible for me to solve, at least without a lot of time and effort in reading the docs. But you need to proceed with caution. So some of the suggestions that I have, some of the things that I've found worked in my organizations and my workflows. The first is that you should make a habit of walking your junior engineers through the trade-offs you're thinking about when solving problems. And this is something you should have done in the era before LLMs, but I think it was easy to sort of not do it because like they wouldn't have been able to, or like it's harder for them to bring you back a solution that doesn't necessarily consider the trade-offs of the problem they're facing. Bonus points if you do this with AI. So for example, if I'm thinking about how to solve a problem or the trade-offs associated with a problem, I might actually show a junior engineer that I'm sitting with the prompts that I would use, the questions that I would ask a large language model to work through that problem. The next thing you should do is you should build a culture that enforces everybody to share their prompts and chat history and whatever other context it is when they're proposing changes. Something that I think would be really helpful is if on every pull request you just share a link to your chat history, that chat history when you were solving that problem. Not always feasible depending on the length of the chat history. Even just something as simple as summarizing the logic you were using and the prompts that you had used when you were generating this response can go a long way in providing context to everybody in your organization. If you're working through a critical or extremely difficult problem, you should take the time to type the solution that you get. If you remember in elementary school when you were learning how to spell, you spent a lot of time tracing letters on paper. If you were learning cursive, you did the same thing. You would trace cursive on paper. And this is actually something that people have been doing for centuries. It's called copywork. Ben Franklin and many other great writers taught themselves to write well with copywork. And it helps when you do the same with AI-generated code. So recently, I've been writing a lot of Go. I have no experience in Go, but I've been trying to learn Go. It's really hard. I don't know why it's really hard. And I found that I was using a lot of LLM assistance when writing Go, and I actually had never learned anything. So I spent like a month of basically asking LLMs to generate Go code for me. And then like a month later, I feel like I had a worse understanding of Go than when I had started because I was essentially just relying on copying and pasting what I was getting. And the problem with that is you don't actually learn anything. So if you're working through a difficult problem and you take the time to sit there and actually type out the response that you get, you sort of build this mental model of how these programming languages work. And the other thing is you start to catch some of the flaws in the logic that you have. If you take a second to just not copy-paste that code, sit there, type it out, you have a much better understanding of the system that you're building. Now, code generation, I think, is the biggest and most useful thing to all of you here, all being programmers. But the usefulness of LLMs in your organization goes far beyond just code generation. But code generation is a big part of it. And I'll talk a little bit about how we can use LLMs and functions that make our teams better. So most people use LLMs and functions where they replace their strengths, and often in worse ways, not necessarily in functions that complement them. So a good example here is imagine you have a marketing team that uses email or SMS or some other marketing tool like MailChimp or SendGrid to communicate with your customers. If you interacted with your marketing team, or if you used any of these tools, you might think that this is the peak of LLM usefulness, where I have some prompt where it's going to help me type up an email or an announcement or whatever. And the bad thing about this is you want your marketing team to be creative. You don't want to offload their strengths to a large language model. You want to use large language models for what they're good at, and you want your marketing team to use to do what they're good at. So one of my sort of radical proposals here is that we should instead use LLMs for what they're good at, such as code generation. So what if we build an internal domain-specific language for outreach campaigns and turn our marketing problem into a code generation problem? We know that large language models are very good at reasoning. They're very good in this sort of structured domain. So why don't we offload that to them, and why don't we keep our marketers working on the things that they're good at, which are creative problems? So this is just something I had had Claude spec out for me. It's a sort of a structured DSL for building an email campaign. You can define segments, templates, sequences, and then essentially an LLM is going to be really good at doing something like this. Now you can do this with all of your business functions as well. If you want to get really radical with it, you could build what is essentially the Terraform for your business. So instead of infrastructure as code, I now have business as code. So I can do this with outreach campaigns, pricing strategies. You can imagine I have a Stripe integration where instead of using a dashboard to edit my products and prices, I have a large language model generate some configuration for me to edit my prices. You can do this with social media campaigns. I've even seen something recently that had done this for video production. So there's a benchmark out there called Theorem Explainer, which uses Manum, which is the tool that 3 Blue 1 Brown, if you're familiar with that YouTube channel, uses to make math animations. And I can imagine a world where we start building these sort of like domain-specific languages for business processes and business functions, so we can use large language models for what they're good at, and then we can do the things that we're good at. This is the sort of tagline I have for this, is stop building dashboards and start building domain-specific languages. Now, I understand that this is like probably a step too far for a lot of people. Not everybody is going to want to learn how to generate code and do things with code, but I think this is something that we should be thinking about in the era of large language models is how can we start using LLMs for things that we're good at and things that, how can we start using LLMs for things that they're good at and then start doing things that we're good at? The best part about doing this all in code, by the way, is that you get to use the best productivity tool in the world, GitHub. If I had my choice, I would have planned my entire wedding on GitHub. But I was not able to onboard my wife onto Git within the span of a few months, unfortunately. Now we need to build our organization systems around the strengths of large language models and the strengths of your teammates. So start doing things that you're good at and let large language models do things that they're good at. Now, the last segment of this talk, maybe the shortest segment, is what does all of this mean to me? And I'm sure I, like all of you, have gone through this, like I said, series of existential crises, thinking about what large language model advancements mean for me and my future career, every decision I've made leading up to this point to get into software engineering. And I think I've settled on sort of a few things here. The first is that this is one of the most exciting times to be a software developer. Things that would have been impossible to build even 3 or 4 years ago are now possible, and it's incredible. You're limited really only by your own creativity and the things that you're interested in. And that was not the case 3 or 4 years ago. And you can learn essentially anything. Now you have access to this oracle that can teach you anything in the cloud. Don't worry about what everyone is doing. This is something that I'm sure you see on Twitter. People say, if you're not doing this, then you're falling behind. And it's hard to ignore that. But the reality is that you shouldn't worry about what everyone is doing, and you should focus on doing what helps you. Remember, we live in a bubble, so this happens to me all the time. I assume that people know what I'm talking about when I start talking about large language models and AI agents, and then I realize 90% of the world has no idea what any of this stuff is. 90% of the people out there are not using large language models for anything, and so you have to keep in mind that we are really living in a very extreme bubble. You should keep an open mind to new workflows and tools that might actually help you. I think as you get more senior in your career, you get more stuck in your ways. It's just a natural progression. And the skepticism you have to new ideas is a good thing. It's a good trait. But you need to keep an open mind, and you need to be flexible, especially with how fast things are changing in this domain. The core skills required to be a successful engineer remain the same. So you still need to be able to solve problems. You still need good critical thinking skills. And that's why it's so important not to offload all of these things to a large language model. These are the things that you should continue to develop, and they're going to continue to be important regardless of how the domain of actually writing code changes. And the final thing I'll say, and this is something that I had to think about a lot in the last 2 years, 2 to 3 years, I saw large language models get significantly better at code generation. It made me think a lot about like what my purpose was. I had a little bit of an identity crisis. I had committed 4 years of college and 5 years of an early career to software engineering. And in a lot of ways, I was like, well, what am I going to do if it goes away? But I've come to the realization that I am more than just a software developer, and you are all more than just software developers. So regardless of what happens to our profession in the next 5, 10, 15 years, I don't necessarily think it's going anywhere. But regardless of what happens, you are more than just a software engineer, and you will be OK. That's it. A little quick. Are there any questions?
Oh, somebody back here.
Hi, thank you for the fantastic talk. I'm Dr. Savage from Mexico.
Hey.
So I would argue that large language models are killing our communities of practice. In terms of, for example, we used to participate a lot in Stack Overflow, sharing what were the best practices, and growing together as professionals. I'm curious if you could, because right now, for example, you shared really good advice about how we can collaborate better around code. But I'm curious if you could also share maybe your vision about how maybe it's also creating generative AI-powered tools that are for collaboration. Because I would argue that right now they focus a lot on the individual, and that's killing our communities of practice. And so I'm very worried about that future of our profession without our communities of practice, that would really push us to grow together.
Yeah, that's a really good question. That's something that I actually have not spent a lot of time thinking about, but it's definitely something I've noticed where, like, I'm not going to ask people questions on forums anymore, and I'm not necessarily interacting with people as much as I was, because in many ways I can just depend on a large language model to do it. I don't really know if I have a good answer for you. I'm sorry to say that, but I really, I think this is something that we're all going to have to reconcile with in the next 5 to 10 years, especially as these communities start to disappear. So I'm sorry, I wish I could give you a better answer. I'll need to think about that a little bit more. I don't want to go up here and just ramble about something that I don't necessarily know much about. Yeah, I appreciate that question, though. If anybody has a good answer to that, please.
We have one question from a virtual attendee, Vinkata. I hope I said your name correct. I appreciate your insights. Could you elaborate on the architectural changes or design principles required to build LLM-native systems, particularly when integrating with legacy systems?
Particularly? Yeah, so I think that was like supposed to be the title of this talk, and I didn't necessarily cover that as much. I think like one of the things, the easiest way to integrate a large language model in a legacy system is using something like structured outputs. So that's kind of why I included that in there. Most legacy systems are like domain modeling problems. So it's how can I model this legacy domain in some way? And the easiest way to plug that in is with something like instructor structured outputs. So yeah, my answer to that.
Hi, what do you think of the state of code completion for Elixir, and what could we do to make it better?
Yeah, I'll admit the state of code completion with Elixir is really bad. Relative to other languages, if you've ever tried to get a model to generate Elixir, it's just sometimes not very good. Most of the time, not very good. You end up wasting more time trying to get it to do something right than it would have been for you to just write it yourself. I think there's a lot of ways we could do these things. So this is, in many ways, I think it's just like selection bias. I think Jose talks about this a lot. Like, there's just not a lot of content on Stack Overflow, for example, for Elixir code generation problems. And so it's kind of a function of like the community not necessarily being as big. What can we do as a community? I think one thing that we could do as a community is potentially build evals around these Beam low resource languages. And like, you kind of force these labs to, they like to benchmark chase. You kind of force them to sort of, hey, how can we push our abilities in these low resource languages up? So building evals for these languages, I think, could be a pretty good way to do that. And then I think just generating more content around these languages, getting more people interested in these languages.
Hi, John Mandalikis. So my question is basically, you said, I can't remember exactly the 3 factors you said, but you said basically like this is just going to keep getting better and
Yeah.
better. What do you think about like the risk that people have raised that, you know, because of ChatGPT polluting its own like data set, right? That like it could actually just get worse over time, and potentially, like you pointed out, like there's that study, I think you quoted 404 Media, like if people are actually getting dumber because of this, might that mean that the model itself will also get worse? Just curious, like, what do you think?
Yeah, I don't think that will have much of an effect. Training data curation is like a really, really challenging problem that a lot of AI companies invest a lot of money in. So I don't necessarily think you'll see synthetic outputs like diminishing or decreasing these model capabilities. I think you will sort of have a crisis of at some point, the internet becomes a large percent of just AI-generated stuff, and it's much more difficult for us to wade through. But the pendulum is going to swing back in the other direction, and people are going to find communities that kind of reject these synthetic outputs at times as well. So I think there's room for both.
We are out of time. Whoa, don't get in front of that. We're out of time for questions right now, but please continue to keep the conversation going. Run into Sean. Sean, I encourage you to check online. There was at least one more question from the online thing, so if you could look at that, that'd be great. Cool. We have a 10-minute break. Everybody give it up for Sean.